Fantastic. Thanks, Celine, and thanks for the opportunity to speak today. So, randomized trials are an important part of the evidence base for policy. They're not the only part, of course. And this trial with colleagues has been a major part of my life over recent years, and it's great to have the opportunity to tell you a bit more about it. I'd like to start by thanking the Independent Data Monitoring Safety Committee. They're a really important part of trials and provide their services without any remuneration, but they are fantastic at giving good guidance, together with the study participants and their families who gave a lot of their time. The funders for my research are listed, and the conflicts of interest, but I have no personal pecuniary interest in the study or any of the other research. So the backdrop is key, and research which started in many ways from our unit in Southampton 30 or so years ago has indicated that a healthy start to life has lasting effects for many organs, control systems. And when it's not quite as it should be, the immediate effects can be subtle. They look like obstetric successes, but suboptimal development can have lifelong consequences, changing how resilient we are and how we respond to later life challenges. So Aline's already shown a derivative of this slide, but it's an important framing. On the vertical axis is chronic non-communicable disease risk. Horizontal axis, life course, i.e. getting older. And of course, as we all age, our risk exponentially increases. And it is possible to intervene in later life in vulnerable groups, which change the risk to a degree. But it's becoming increasingly clear that early life is an effective time point to fundamentally change that risk trajectory. And this is really critical in tackling disparities in health. But even more so, that childhood and adolescence is an effective point for the next generation. And in recent years of my research career, the focus has been very much on preconception. Some 5 years or so ago, with colleagues, we published the Lancet series on preconception. And in this one of the papers, we pulled together the scientific experimental evidence that preconception truly is a critical period, not just for maternal effects, but for effects of the father's nutrition, obesity, mother's obesity, overnutrition, undernutrition, but also of assisted reproductive technologies, which change the immediate and lasting phenotype. So WHO pulled together some 10 years ago now the investment case for investing in preconception health and care. And sadly, my view is that it's rather sat on the to-do, too difficult pile. And if we're really serious about tackling disparities in pregnancy outcomes and in health, that can no longer be the case. So in the UK, we're working strongly with government to try and change that at the moment. So a start to that, pulling together the research agenda and research evidence, National Institute for Health Research 5 years ago, and with our national public health body, Public Health England, we may produce some materials making the case for preconception care. And these will shortly be revisited with what is now the Office for Health Improvement and Disparities. One of the other papers in the Lancet series argued that the preconception period represents a special opportunity for intervention, not just in biological terms, days to weeks before embryo development, but for individuals in the conscious intention to conceive, weeks to months, but importantly in public health terms, where you've really got to be looking over a months to years time frame to address aspects such as diet and obesity. It's always been the dogma that it's a minority of women and couples who prepare for pregnancy. But when we have better tools for measuring that, it actually indicates that it's probably the majority that do plan, at least to a degree, at least in Western settings. And of course, micronutrient supplementation, it happens in pregnancies and it can correct some deficiencies, but it's not sufficient to fundamentally improve child health. And dietary interventions, you know, we can change gestational weight gain to a degree, but also it's been disappointing in terms of improving pregnancy outcomes. Too little, too late, in my view. So in recent analyses of around 1/3 primary care records in the UK, we've published that over 90% of women have some preconception lifestyle or medical risk factors for poorer pregnancy outcomes. 60% behavioural lifestyle factors, 1/3 more medical factors, and 1/5 both medical and behavioural ones. It's not just important for pregnancy outcomes, but these early life perinatal preconception factors seem to matter for the epidemic of childhood and later adult obesity in the world. So some years ago now, in our Southampton Women's Survey, we published on an aggregation of perinatal risk factors, 5 of them listed on the slide. And when there were 4 or 5 of those, there was a more than 4-fold increased risk of the chance of the child being overweight or obese. Cigarette smoking is associated with a 1.9-fold increase in the risk of lung cancer. So these are substantial risks. And in the Gusto Singapore cohort, where we additionally had information on maternal glycemia and on the father's overweight, the risk was over 10-fold in those with multiple risk factors. So could something pre-conception and during pregnancy tackle this? And this is the backdrop to the NIPA trial that we embarked on. So nutritional intervention, preconception and during pregnancy to maintain healthy glucose metabolism and offspring health. A bit of a mouthful, so I'll refer to it as NIPA if you don't mind. So it's a preconception and pregnancy, academic-led randomised trial with my colleagues Wayne Cutfield in New Zealand and Chan Xiaoying, who's here today. The population, preconception women. I'll talk more about the intervention and why it was chosen, the comparison, the standard composition of micronutrients, and the outcomes. The primary outcome was chosen as maternal glycemia, but with a range of secondary outcomes pre-specified in the gov.trials registration. So double-blind, randomized trial design, major undertaking. Over 1,700 women were recruited. The outcomes I've talked about, but we also collected biosamples, measurements from the mothers, the partners, and the offspring as a discovery platform for observational and future intervention trials to be designed. So why the primary outcome? Well, most will be aware of the HAPO and other studies showing a continuum of risk for a variety of outcomes across the maternal glucose range. And those studies led to what became known as the developmental overnutrition hypothesis, as set out by Debbie Lawler and colleagues, whereby higher levels of glucose and other nutrients, very important, were associated with intermediaries that were proposed to increase adiposity throughout life. So how could we go about improving glycemia? So around the time of the design of the study, there were three groups of components where there was interest and linkage to glycemia, and suggested that a nutritional non-pharmaceutical intervention could be helpful. So the first of those related to myo-inositol, and there was a great parallel session on myo-inositol at this meeting. I won't go into the detail of it now, but it's thought to act as an insulin sensitizer and to be associated with insulin mimetic type actions, as set out on the slide here. There were, at the time of the design of the trial, some and subsequently been more trials of myo-inositol supplementation showing decreases in gestational glycemia at 24, 28 weeks, such as this meta-analysis shown here. However, these trials shown in the meta-analysis, they're all from in Italian women, they're in individuals with risk factors for gestational diabetes, polycystic ovary syndrome, high BMI, etc. And they all commenced myo-inositol for around 12 to 13 weeks gestation. And so they are what they are, but how generalizable they are is an open question. Some of the work that Xiaoying's team in Singapore have done has really encouraged us that myo-inositol may be an important player. And in these studies measuring placental myo-inositol, it was found that in those with high myo-inositol level, when we did MRI scans of the newborns, the higher glycemia in those women with high placental myo-inositol, those higher glycemia levels were not associated with greater adiposity in the neonate, suggesting that the high myo-inositol levels are protecting the fetus from the adverse effects of maternal glycemia. The second component of the NIPA supplement relates to two probiotics, which again, there are trials out there linking these particular and other probiotics with lower fasting glucose and reduce homoinsulin resistance, which are summarized on the slide here. And the third component of the NIPA intervention was a group of micronutrients. And again, in another one of the parallel sessions, there was some of the nice work linking B12, particularly low B12, particularly in the setting of high folate, with gestational dysglycemia and gestational diabetes. And there are other B group and vitamin D studies linking to glycemia. So we selected a basket of these as a part of the intervention. So what did we end up trialing? So in the control group, participants received standard 400 micrograms of folic acid, preconception and during pregnancy, together with iodine, a small dose of iron, beta-carotene, carotene, and calcium. The intervention group also received the same dose of myo-inositol that was part of those trials that I showed you. The dose of vitamin D3 that is recommended in the UK, and B6, B12, B2 riboflavin, together with an amount of zinc and 2 probiotics, which I'll just say a bit more about in a moment. So myo-inositol, naturally produced in the body, it's produced by gut bacteria. We eat it to a degree. The probiotic was these 2 Lactobacillus rhamnosus and B. animalis, linked with a reduction in GDM, and then these micronutrients. And it was taken as a drink twice a day during preconception and pregnancy, but stopped at delivery. So with much effort, but actually it was achievable, we recruited just over 1,700 women, randomized them to intervention and control, and undertook GTTs baseline 24, 28 weeks gestation, and then have been following up the offspring. When people heard we were doing this, they said, well, you'll only recruit those high socio-demographic individuals who really want to take part in trials. You won't get a good mix. But actually, we did get a good mix across sites, ethnicity, preconception, BMI, parity, and income, household income. So we were disappointed, to be honest, with the primary outcome, but it is what it is. And we found no difference in gestational glycemia at 28 weeks between the control and the intervention groups, with remarkably similar fasting 1 hour and 2 hour plasma glucose levels. We found no difference in gestational diabetes or in birth weight, but the intervention did reduce preterm birth by a pretty substantial degree. And it was particularly preterm births associated with preterm pre-labor rupture of membranes, perhaps the major biological category of preterm labor. And it was particularly preterm labor associated in late preterm and preterm delivery associated with pre-prom. So, of course, neonatal practice is dominated by extreme prematurity. And the question is, do these late preterm births that we prevented really matter? But in population terms, if you look at the pyramid, the burden of neurodisability that arises from preterm delivery, it is driven by the greater numbers of late preterm births, simply because they are numerically so much greater, and they are at risk of greater neurodisability. And it seems that the inflammatory process associated with PPROM may be particularly important in that. So we do suspect that we may have done something beneficial in terms of the offspring outcomes, but we're following up the offspring to find out whether that's true or not. Were we surprised to find an effect on preterm birth? To be honest, we weren't, and it was pretty much our sort of second primary outcome. Of course, you're not allowed to have second primary outcomes, but in all our registrations and things like that, it was a key outcome where there was a priori data from other trials that myo-inositol supplementation was associated with a reduction in preterm delivery. Were any other outcomes altered by the intervention? Well, there was a reduction, a pretty substantial reduction in major postpartum hemorrhage, which was in many ways unexpected. And I think that this requires replication, but it may well be a valid, a true effect. And Xiaoying's recently led the analyses that have shown that there was a reduction in the delay in the second stage of labour and a reduction in the time in the second stage of labour. So these may link together, further work to be done there. We were hoping that the intervention might overall reduce the time to conception in the population. And we didn't find that, whether you looked at the clinical pregnancy rate at 3 months, 6 months, or 12 months. There were remarkably flat associations. But in the subgroup analyses, we found a suggestion, not statistically significant for what it's worth, that intervention may exacerbate the already delayed time to conception among women living with obesity, but that intervention might reduce time to conception in those who were overweight. And in fact, the reduction brought the intervention group down to a lower time to conception that was pretty much identical to that in non-overweight or obese women. So is this overanalyzing the data? Is it a real effect? We suspect it could be a real effect, and that different things are happening in those women who are living with obesity, who tend to have higher rates of metabolic syndrome, etc. But that's awaiting further replication, further analyses. Have we been finding anything else out from the analyses to date? So we've undertaken a preliminary study of microbiomes in the mother and offspring. And not surprisingly, there are different microbiome profiles in the mother and in her infant. What was interesting to look at was where there were strains of bacteria that were truly passed from mother to offspring, that they had different functionalities in the mother and the offspring when you looked at the transcriptomes of these bugs. So the environment in the mother's bowel is, of course, very different to that in the infant bowel. So when we're moving into this era of microbiome-related studies, we really need to move beyond just simple consideration of what species are present to think about what they're doing, what metabolites they're generating, etc. And that work has started within the study. We also collected breast milk samples from the mothers in Singapore and New Zealand. And remembering that the intervention stopped at delivery, we were interested to see that the preconception and pregnancy intervention increased the zinc content of the human milk in the mothers in the intervention group. And of course, we need to work through the follow-ups and the data to see whether that had any benefits to the health and development of the offspring. And the final couple of slides I'd like to show
are from data that has only reached the public domain in the form of an abstract at the recent Lancet Obesity Summit. But in following up the offspring to 2 years of age, Jazz Lyons-Reid in New Zealand has shown that there is reduced weight gain from birth to 2 years in the intervention group. And when you look at the children at age 2, there is a reduced risk of the child being obese greater than the 95th centile. And interestingly, there's also a reduction in those who are underweight. So it's not just a downward shift in the distribution as such, it's a narrowing of the distribution. And we wait to see whether these results play out during later childhood. So those are in play at the moment. Those are crucial because micronutrient deficiencies are more common among those in disadvantaged groups. And if there is a way to tackle this serious widening in disparities in childhood obesity, this is national data in the UK, and in spite of sugar tax and everything else we're doing, those disparities are ever widening over the last 10 years. And if we can fundamentally change appetite or change metabolism in a way that reduces the risk of the less advantaged in our obesogenic environments, it will be really important. So just to pull it all together, the NIPA intervention was associated with no effect on gestational dysglycemia or birth weight. There was a shorter time to conception in overweight, but not obese women, suggestion of going the other way in obese women. A reduction in preterm delivery and PPROM, which we feel is robust, it's consistent with the literature. A shorter second stage of labour, reduced postpartum blood loss and major PPH. And emerging data and lots coming through but not yet in the public domain relating to offspring outcomes, transcriptional shifts in the gut bacteria, changes in human milk nutrient composition, and interestingly, a reduction in childhood obesity. So thank you for staying into the evening, and I hope that was of interest.
Thank you, Keith. We will do Q&A at the end of the session. Oh, sorry, maybe top-line question, Keith. What was the rate of GDM? Let's not keep that until the end.
So the rates of IAD, PSG, GDM were 17%, 18%, and I think high 20s% across the 3 sites. So we did find significant GDM.
And also percentages in line, I think, with earlier reports, if I may say so. Yeah. Yeah. Okay. So I would like to continue and introduce to you the second speaker. But before I do so, everyone found this leaflet on their seat, and we would really appreciate if you could fill it out and hand it over to the person that's waiting at the door later, so that we have an idea what you think of the session.